Okay, we got to compete with the tacos and the enchiladas. I want to take a quick poll before I start the presentation. How many of you here have ever been on 6 meters? Okay, it's basically everybody. Can anybody tell what's wrong with this picture? That's my station at home. I'm here making a 6 meter. What's it? Oh, awfully neat. You're a good man. I need you to talk to my XYL. What's that? So you're close. I'm here making a 6 meter presentation and everything in the picture is on HF. So all righty. So can we go to the next slide? So I'm hoping that in the presentation today that we can make this more of a conversation as opposed to a presentation, because I think you're with all the 6 meter guys that we've got in the room and ladies, that there's a lot of experience in here. Good, good. Okay. So look, just real quickly, I was first licensed in 1967 in upstate New York. So I was a W-2 before I became a 7, then a 6. I've got 349 all time. All I need is P5. That's the only one I haven't worked. So anybody here got P5? Doggone you, Rick. Member of the Northern California DX Club's board of directors. I was founding member of the Central Arizona DX Club back in the day. And I've got one lovely daughter who's a psychiatrist, which is prophetic, actually. And I spent 22 years chasing bad guys. So I'm seriously disturbed. Next slide, Bob. Thanks. I'm sorry? Oh, sheriff's office for about half of it and Campbell Police Department for the last half. Yep. Yeah. I'm sorry? Oh, great, great town. I love Campbell. Okay. I wanted, I didn't know how many people here would have been experienced 6 meter folks. So I came here prepared to tell you all the reasons why you ought to be on 6 and all the reasons why you might want to consider some other hobby. Yes, sir. Okay, well, I'm going to convince you. So on the positive side, the operating challenge on 6 meters is significant if you're a DXer. 6 is one of those bands where it's relatively easy to make continental QSOs, especially during the E season. Easy peasy. Almost anything that radiates will get your contact on 6 continental. DXing though is a significantly different challenge on this band. Also, it's a learning opportunity. There's certain aspects of DXing on 6 that are unlike any other band. It's what I call a transitional band between HF and true VHF. So it exhibits characteristics, that you see, typically on 15, 17, 12, 10, and also characteristics that you see on 2 and 220 and 440 at times, depending on your operating style. And it also, in my opinion, requires a fair amount of technical competence. It's a noisy band. You just throw a piece of antenna up in the air, and what you're going to do is you're going to get a whole lot more noise than you're going to get DX. I don't know if any of you have noticed that. It's also, a constant battle of, trying to improve your noise figure, trying to improve your signal to noise ratio. FT8, as I'll talk about a little bit later on, has made that somewhat of an easier lift for most of us. But in, most of the time that I've been a ham, I've been a CW operator. And, the advantage that FT8 has brought in terms of bringing everybody together in one watering hole where you don't have to continually tune the beacon band looking for, where propagation is coming from has been a significant enhancement in terms of working new countries. On the negative side, time in the chair. And I'll show you a couple of examples of this, but if you're not sitting in the chair, you're going to miss a lot of DXCC entities. It's not like HF where let's say I need to get JY5IB or whatever on a couple of band slots. And you can usually find him active at the same hours, and on one of 2 or 3 bands, you can just chase them and nail them. On 6 meters, there are openings that last 30 seconds, 1 minute. That's your one and only opportunity you're going to see for 11 years potentially. Another negative is that to be serious on 6 as a DXer, it has a huge impact potentially on your time in HF DXing. And so I learned really quickly that you need to be able to monitor 6 meters while you're HF DXing. If you take your eyes off the band, the opportunity often goes away before you know something ever happened. And then, I've already alluded to this, certainly down in San Jose where I live, I'm 880 feet above the valley. And when I look out over San Jose and up into South San Francisco and, the cities north of me, the noise level just comes straight up. So it's constant battle. And most of it is noise that can't be mitigated, or at least can't reasonably be located and an attempt made to mitigate it. So you have to find creative ways to work with your receiving gear, to do the best that you can. Next slide. Okay, let's see. Can you go back one slide? Okay, yeah, that was the next slide. I'm sorry. All right, so here's my pitch. How hard could it be to DX on 6 meters and get DXCC? As of a couple of weeks ago, there were a little over 92,000 licensed amateur radio operators in W6 land. Of that, I am only aware of, and I'm not swearing that this is 100% accurate, 16 have DXCC on 6 meters. That gives you an idea of just how difficult it is to get it from the West Coast of the United States. Now, this is a list that's maintained by Russ, K6KLY. So I think that he does a pretty good job of trying to maintain, who's on 6 and who's doing what in terms of DXCC. But you can see that the Motherlode DX Club has a couple of call signs on here that have DXCC on 6. W6SR, obviously N6JV is way up near the top there. I've got my reading glasses on, and unfortunately I should have worn my regular glasses, but you can see W1SRD has DXCC on 6. Have I missed anybody in this room that has DXCC on 6? Yeah, that's Fred. Fred actually has 2 DXCCs. He's got one from California and one from Hawaii. And I'll tell you, if you ever want to listen to Fred's stories about the propagation conditions in Hawaii, it's really something to behold. And I saw him make a lot of these fantastic cues that he'll talk to you about. So I'm sitting at 114. And I'll tell you a little story. Being a confirmed CW guy, I was one of the last dinosaurs that actually decided to operate FT8. On 6 meters, if you're not on FT8, you might as well just turn the receiver off and go away. Unless there's a contest, there's literally 0 sideband and CW activity on 6 these days. Now there's pluses and minuses to that. Yes, sir. Not much anymore. Not much anymore. But again, the main message on the slide here is that if you're serious about DXing on 6 and trying to work DXCC on 6, be prepared for the long haul, because I've been at it for 22 years. It took me 22 years to get to 114. Norm, how long did it take you to get to your country count today? About 20 years. So there you go. Rick, how about you? Oh, you're a slow guy. Persistence counts, that is for sure, on 6. Okay. Here's what I was talking about with things moving quick. These are not particularly noteworthy cues, but they're representative of what I see, continually. On the left, you'll see an FTA QSO with Bravo X-ray 9 alpha alpha. It was at 02, 0200 hours, which is a very common time frame for working Asia on 6 meters. Summer solstice, short path, or, we'll get into that in a little bit. That opening lasted 3 minutes. 3 minutes. If you needed BX or BY and you weren't sitting in the chair that day at that time, you missed it. On the right is an opening into South America. That was just this last year. Nothing remarkable about HC other than it's a good indicator for much further south into, potentially into far southern South America, maybe even the Antarctic. But you can see that happened in the morning, 1836 hours. That opening lasted 14 or 15 minutes, and then everything disappeared. So again, if you're an HFDXer, like I think everybody in this room is, I'm certainly that, and so is Tony. If you don't have a weighted monitor 6, or you're not looking at specific times because the path is there, you're not going to see these things happen. They're gone pretty quickly. Next slide. Time in the chair. That's me after, let's see, 3 years. I went 3 years before I decided to go to FT8 without working a single new country on CW. 3 years. Next slide. Okay, let's talk about propagation modes for a minute. And some of this is old hat to you guys because it's not, hugely different necessarily than HF. The predominant propagation mode on 6, and when I say predominant, what I mean is it's the most predictable. It is the most common at a certain time of the year is sporadic E propagation. And I'll show you the mechanism there in a few minutes. And that's followed by at other times of the year, trans-equatorial propagation, TEP. Very, very different propagation modes, very different times of the day. They sound very different, regardless of which mode you're operating in. And then there's a third mode. There's a third mode called summer solstice short path, and there's a lot of controversy around SSSP. There is a big segment of active 6-meter DXers that believe that summer solstice short path is a different mechanism than multi-hop E's. And I'll show you what's going on there and what I think is going on. During time periods where the solar cycle is at its peak, you see what's called TEFE, trans-equatorial E's to F propagation. And again, that's very different than any of the others. We also have propagation that's called spread F or spread F2. You see that on HF, quite frequently. And then there's long path, which is a very infrequent occurrence. I've only, I think out of maybe 10,000 QSOs I've had on 6, I could only assert that I think 2 of them were long path. 2 of them. So it's very, very rare. Yes, sir, Steve. I'm sorry?
The one in Chile that we hear frequently?
Yeah, CE2SV probably. For me, he's typically 130 to 140. It's yeah, that's usually TEP. Yeah, usually TEP. There occasionally I have copied CE2SV and a couple of his cohorts down there on multi-hop E's, but you figure when you look at the distances and how a single hop E is typically anywhere from 1,200 kilometers to 2,200 max. It does the numbers don't work out very well for a multi-hop E into CE. I'm not going to talk today about non-DX terrestrial modes like aurora, ionospheric scatter, meteor scatter, although they're very interesting modes. And if you're a grid hunter, which a lot of folks on 6 are grid hunters looking for FFMA, these modes are indispensable, for filling in grids, particularly that are relatively close to you. And then lastly, I'm not going to deal with EME because that's a subject matter all to itself. And I don't know anything about EME other than it's Q65. So Norm back here, could probably do a whole presentation on EME, I would suspect.
So I do have a question.
Yes, sir.
Rick and Norm, are your DSCC counts including EME? Yeah, I am. Your DXCC count including EME? Yes.
Yeah, my 114 is all terrestrial. At least as far as I know. Certainly wasn't EME by intention. Next. Sometimes folks have, atmospheric heaters, they don't know that their main lobe is 30 degrees in the air. But, sporadic E. So this is worth talking about because a vast majority of your 6-meter DX contacts are sporadic E. And what really is going on here is that the atmosphere, if you will, at a particular height has a lot of metallic atoms floating around in it, and they get ionized. These metal ions get ionized by solar radiation, and they also get ionized by geomagnetic induction, if you will. So the mechanism that's going on here is that these atoms get ionized, and then you have the trade winds which blow in one direction, and you have lower level winds that are blowing in another direction, which compresses these ions into patches, if you will. And the patches can be quite small. Some of the ionospheric patches, might be as small as a few meters across. And some, get to be extremely large. They could be miles or kilometers in diameter. So that's the mechanism that you see on the left. Sporadic E propagation is typically 60 to 80 kilometers in height. That's where the E patch is going to be, is right in that 60 to 80 or maybe even 100-kilometer region. And on the right, you see a PSKR map. And what's notable there is you can see, if you look at the eastern seaboard, there are 3 distinct E patches that you can see running up the East Coast, and then another very distinct patch that's in the upper Midwest. That's very typical of what you will see with one-time E's, one E pop or one E hop, if you will. You also, notice the path from the Caribbean into the East Coast, and you'll see that quite often early in the morning here on the West Coast. The propagation will fire up from the Caribbean or even from Europe into the East Coast, although that's multi-hop E's from Europe. Next slide, Bob.
Question?
Yes, sir.
What DX maps every day the East Coast opens up and it just never gets out of the West? What's going on?
Yeah. Yeah. So the question was that oftentimes you're monitoring PSKR and you see that there is propagation, East propagation on the East Coast or even Midwest and then into Florida, but it never moves that way or this way to the West Coast. What's going on? There is some conjecture. I'll talk about it a little bit later in the presentation about the direction that E's typically move with the sun. But oftentimes what's going on is that the E patches are being ionized, if you will, the metal ions that are ionized by geomagnetic disturbances or by thunderstorms. And we don't have a lot of thunderstorms out this way, as an example. So, these ionization mechanisms don't always occur uniformly across the country. So that's my supposition. Let's see, TEP, transequatorial. So what you've got going on here, I've provided you with a map on the left that shows the TEP zone, if you will, that goes completely circumnavigates the world, if you will, with the actual geomagnetic equator is that middle thicker blue line, and then the upper and lower boundaries to, above it and below it are sort of the TEP region, if you will. And on the right, you can see what's going on is that the RF signal enters an E patch, if you will, or an ionization patch on one side of the transequatorial zone and makes a straight chordal hop, if you will, across that bulge at the transequatorial or at the equatorial bulge and hits another E patch and then back down to the ground. And so one of the things that makes it relatively easy to tell TEP if you're on SSB or on CW is you'll hear distortion, flutter, really severe flutter in the signal. On FT8, what you're going to see when you're experiencing TEP is oftentimes the signal will broaden out. It'll appear to be much wider than 60 hertz. Okay. And yeah, exactly. The signal will broaden out. I've seen TEP signals that are sometimes as wide as 80 or 90 hertz. So, you know, like 50% wider than a clean signal. But again, if you look at this map, TEP is always going to have a contact that is south of the magnetic equator to north of the magnetic equator, and generally outside the bounds of or crossing the entire equatorial region that you see there, 3 lines. That propagation, by the way, is very, very common in the fall, which I'll get to as well. Next slide. Summer solstice short path. Now, I'm going to caveat this by saying that there are a fair number of disbelievers in what is the mechanism that's going on here. The folks that have researched this think that what's going on is that there is polar mesa ionization. Ice crystals are actually becoming polarized. They form this large reflective region that you see at the top there in that heavy blue or black line. And, you know, if you're sending a signal up, you need an ease connection to that somewhere, right? And then it enters sort of quarterly this polarized ice crystal region, if you will, and propagates along the underside of that and then exits somewhere on the far end, again, potentially with a small E connection to the ground. And these paths generally, by the way, extend from 8 to 12,000 kilometers. And it is a summertime phenomenon. It only occurs in our summertime here in the Northern Hemisphere. Now, there's a whole community of 6-meter enthusiasts that say, this is BS. This doesn't exist. That the believers say, hey, all you have to do is go to NOAA and look and read their studies about PME, polar mesa, whatever. And it's obvious what's going on here. There's a bunch of folks, though, that say this is really nothing but 3 or 4 times E hops, right? Now, I'll tell you, I struggle with, I've made contacts that were SSSP that were 12 to 13,000 kilometers long. What are the odds that you would get 6 E clouds aligned? I don't know. Norm, you might have an opinion. Rick, you might have an opinion. I personally think it's a different mechanism than traditional multi-hop E's, you know, because of the very specific time of the day, very specific, usually a 1 or 2 hour window. And again, what are the mathematical odds that every single day or every other day for 2 or 3 months, that path exists for 8 to 12,000 kilometers? All the E clouds are just lined up perfectly. It just doesn't seem reasonable to me. So I'm a believer that SSSP is a different phenomena than multi-hop E's. Next slide. Okay, then remember we said TEFE, trans-equatorial FTEs. What you got going here, you see the 2 lines that are circumnavigating the globe. That's the same TEP region that we had on a prior slide. So certain stations like KH6Y or KH7Y in Hawaii used to work this mode a lot, and he made some great contacts, DX contacts, because he is positioned in a way where he could beam at a very gentle angle into that TEP zone. And you get a bunch of chordal hops bouncing around in there. It goes all the way around the world and then decides on its own where it's going to exit. Don't ask me how it decides to exit, where it chooses to exit. I have no clue, but I've seen it repeatedly. KH7Y is the best example of this. Folks that live in a place where they can enter that TEP zone at a gentle angle work phenomenal DX. That's why you see on 6 meters, the PYs, the PYs that are on the East Coast of South America are in that perfect area where they have high geomagnetic activity. All the geomagnetic lines come to bear right there. and they're in a place where they can point their antennas and enter that zone at a very gentle angle, which is very different than us, right? When we're beaming that way, we're heading down there at a very steep angle. And so it's likely just to, exit straight through as opposed to glancing off and, bouncing around. So there's been contacts that I've seen other people make in this particular mechanism that have been antipodal, essentially antipodal to them, 18,000 kilometer QSOs using TEFE. Yeah, go ahead. Our Hawaii brother, have you experienced this?
Yes, I have. The one time that I got a chance to work from KH6 to Europe, I was aiming at VKZL. So that must be something similar.
Yep. Yeah, that's a perfect example. It's also why 3D2AG and E51WL and those guys that are very near the geomagnetic equator work long path into Europe pretty consistently and into Africa, and we're hearing nothing, absolutely nothing. Right. Again, they're entering that TEP zone at a very gentle angle and glancing around, coming out somewhere way on the other side. Next slide. Okay, F2 spread F. Don't need to say much about this. This is, a propagation method that we see on HF all the time, and I think you guys are very aware of it. The difference here, of course, is that the reflection layer, if you will, is much, much higher in the atmosphere. It's typically 200 kilometers as opposed to E's, which is, 60, 80, 100 kilometers max. But again, this is you don't see spread F on 6 meters except when the solar cycle is really at its peak, minus 1 year from the peak and plus 1 year from the peak. Solar terrestrial indices have to be, 250-ish, for a solar flux. And quiet A and K, numbers for this to be apparent. See a lot of transcon in the US. This past year, I worked dozens and dozens of New York and Massachusetts stations. You're working spread F when you hear nothing in between, right? You hear W6s that are your neighbors, and you hear W2s in New York City and nothing in between. Next slide. Long path. Now, again, I would say that you'd be fortunate if you had more than a couple of Qs in your lifetime on long path on 6 meters, but it does happen. One of my long path contacts was 9K2GS. I was beaming 140 degrees and worked 9K2GS, or at least that's assuming that he's not using a remote somewhere in South America. He claims not to be using a remote, so I'll take it. But you remember the TEP example I showed you with the equatorial bulge? Well, here what you've got is two equatorial bulges. You got the same condition where a station is entering at a shallow angle. They entered that bulge area and then follow it around quarterly and exit the other side, antipodal, at the equatorial bulge. That's what's happening with long path on 6 meters. Next slide. Field aligned scatter. I only put this up here. This isn't necessarily a big DXing propagation mode, but you need to be aware of it because an awful lot of times on 6 meters, you will point your antenna where the station should be, but it's not there. You don't hear him. You need to watch for FAI, skew path, if you will. That is very frequent. It's not unusual on 6 where the true beam heading yields no fruit. You skew your antenna 20, 30, 40 degrees, and all of a sudden they're there and good copy. And that's what's going on there is field aligned scatter typically. Next slide. Okay, I put this in here because there's some portion of the typical year where it pays to know what kind of propagation you should expect to see because it predicts what time of the day you should be operating and where you should be looking. And it also is helpful in terms of, maximizing your time on other bands when it's less likely to be fruitful on 6. So let me start at the bottom with sporadic E. Sporadic E season typically will start in May, this month. There's some years where it might be mid-May, right about now, coming up on right about now. Sometimes is it to the end of May or even into the early part of June. And will typically extend through August or maybe even into early September. My experience in it, and it may be different, you folks may have seen something different, but typically the season starts in earnest right around the 1st of June, and it's winding down by the end of August, right? So if you're a 6-meter DXer and you're planning on taking a vacation to Italy in June, you're a nutcase. You're not serious. Either that or you got a wife, one of the two. So you want to make sure you're in the chair as much as you can be on 6 meters from, basically the middle of May to the end of August. That's the hot time. Before that, and after that, you've got TEP. So TEP is a really good DXing mode, basically from January to March, and then again from October to December. So there's a very long TEP season, which tends to be somewhat shorter at the low, at the lower end of the sunspot cycle, and tends to be somewhat longer, when the sunspot cycle is at its peak. So you can't miss. You shouldn't avoid looking at 6 meters for for the non E season part of the year, but you might keep an eye on the band while you're on HF. Meteor showers and aurora, basically happens a lot during the year, but it's not a DXing mode. So what's the takeaway from this? Be in your seat from the end of May for sure through August, the end of August. That's when you're going to work most of your DX into Europe, into Africa, and so on and so forth. But don't ignore TEP because a lot of good contacts happen. I worked 5W1SA on TEP. Let's see what else. Cage 0 on TEP just this year. So it's a good mode. Also, let's see. Why don't we go to the next one because I think that covers. Okay, yeah, it's later on. This slide. Couple of tools. You guys probably already use them for HF DXing purposes, but for 6 meters, you want to be on PSKR and you want to be on DX maps. Okay, those are the two primary tools that I use to spot where openings are and how they're progressing. That plus ON4 KST for those of you that don't mind watching the chat. Again, you can get a really good idea. The one on the right was an opening that I was working. You can see it was pretty good into Europe on that particular day. Yeah, there you go. Nice JA opening. Yep. Next. Okay, so let's see if I can summarize all of this. Again, you guys all have other things that you like to do, both inside the hobby and outside the hobby. So I'm trying to provide a little guidance here in terms of when to be on 6 or when to be at least attentive to 6. Daily peaks. Typically on the West Coast, 1500 to 1800 is an important time, as well as in the early afternoon, 21 to 01. So in the morning, during the summer, 15 to 18, or even maybe a little bit later than 1800 is when you should be looking for Europe and Africa. Also potentially the Caribbean. 21 to 01, you're swinging your antennas up towards Japan and China. And 05 to 10 UTC, oftentimes you'll catch second openings into Asia, and they tend to be a bit longer. The path is longer at the later hour. So those are important times to keep an eye on. Also, it's interesting on 6, what you see happen on a particular day tends to repeat itself 27 days later. The solar rotation is 27 days. So if you had a particularly good opening today, look for something similar to happen 27 days from now as the solar rotation completes. And then, of course, there's seasonal effects. We talked about E's being a May to August phenomena, so that there's certain things that happen during the summer with E's and multi-hop E's in particular that won't repeat, again during the rest of the year until you get back to the next E season. TEFE is an October, December type thing. But again, when the solar cycle is at its peak, and TEP is January to May, if you will. This year, because we were so high up in the sunspot cycle, it actually started in October, Norm? So it was actually a couple of months earlier, but you'll see really good TEP conditions, even when the sunspot cycle is not at its peak. One final note on this, there is no correlation, none, between where we are in the solar cycle and the quality or quantity of 6-meter E's, sporadic E's. Does anybody here remember WA5IYX? Yep. Okay, Rick does, and I'm sure Norm does. He did a study over 30 some odd years. He was monitoring commercial FM stations up in the 80 megahertz region. And he correlated the number of days of EHOP that he could record versus where we were in the sunspot cycle over multiple sunspot cycles too, to be specific. And there actually is a lack of correlation. And it appeared to me when I'm looking at the data, like the best E seasons tend to be 3 to 4 or maybe even 3 to 5 years out of phase with the peak of the sunspot cycle. So don't walk away from here thinking that the only good things that happen on 6 happen when, solar flux is 250 or 270 or whatever. It's exactly the opposite when you look at sporadic E's, which is the main propagation mode on 6. Okay. Yeah, Rick.
W2 BOC. Oh, bad feet.
All right.
Sorry. Anyway, Mel, W2 BOC, now an SK, also did extensive work on E's. Came up with that. I remember reading that about 1970, early 1970s.
Yeah, again, it's there's some mystery in this. There's still a lot of science being done, in propagation in these frequency bands, and it's not. To me, there's never an end to the mystery of how some of these propagation modes occur and how they repeatedly occur. And the FT8, by the way, has made it so much easier to discover paths that we never knew existed before. If you go back 10 years ago, nobody ever heard of SSSP as an example. Some of these trans-equatorial paths nobody knew about. They never pointed their antennas that way. And with everybody on the same watering hole now, we're discovering these things are happening. Next slide. Okay, equipment. So I'm not going to weigh in on this other than to say that when you're in the middle of the E season, almost anything is going to be just fine. Okay, if you can put out 100 watts and you've got 2 elements, you're going to make plenty of contacts. But if you're a serious DXer, you're going to be left wanting to do more, and 2 elements is not going to cut it. You need to think in terms of making sure that whatever transceiver you have has 2 VFOs, unlike my IC 7700 that has only 1 at a time. So you can monitor HF and 6 at the same time. Or in a lot of cases, you set up 1 VFO on 313, 50.313, and the second VFO on 50.323. So a lot of the folks, when it gets crowded on 313, especially the DX, will move up to 323. 5 elements seems to be the sweet spot. I have run everything from a 3-element Yagi at 35 feet to 14 elements at 100 feet. I'm currently running 10 elements at 82 feet. The only time that a huge long boom at very high heights, relatively speaking, makes a big difference is when you're either the first one to hear them or the last one to keep copying them, or the signal is so marginal that, every 10th of a dB matters. Of course, that's a big duh to you guys. You all know that, right? Most of the time, 5 elements on 6 meters is going to be a very competent setup. Now, sort of counterintuitively, you do not need to have a 6-meter antenna 70, 80, 90, 100 feet in the air. In fact, it's probably counterproductive. I think Norm would attest to the fact, Norm hears probably better than almost anybody that I know in California. Norm's running 7 elements at 25 feet. Yeah. I think that, and I've been told by more than one person that 22 to 25 feet is about the optimal height. That's one wavelength above ground, right? So there's really no need to get it up really high. And there's really no need, except in extreme cases where you need 10 elements on a 50-foot boom, to be honest with you. Having trouble reading the rest here. One thing that I would note, though, is that QSB, is much more severe, I think, on 6 meters than it is on a typical HF band. And so if you really wanted to push the boundaries, a stacked set of 5, actually helps with QSB quite a bit. Again, it's mechanically a little bit tougher to achieve, but 5 elements is pretty manageable on 6. So 2 5s in a vertical stack or in a horizontal stack, which is tough because you need an insulated boom. But if you have a clear horizon, a vertical stack of 2 5s really helps with QSB a lot. I was running a vertical stack at 2 7s until a storm took it down. And I very seldom experienced QSB that was a problem relative to previous to that. Yeah, you can get away with a lot on 6. I was running about 19 feet apart. So a little less than a wavelength, about 8/10. Yeah, I was running my stack at the lowest antenna was at 72. The highest antenna was 18 feet above that. But to be honest, that stack at 25 feet probably would have done better. I would have been hearing less noise from out in the city, and probably getting better ground gain from having the antenna lower. And then low loss feed line. The every 10th of a dB counts, and it's not so much the power that you're putting to the antenna as you want to have the lowest possible noise figure that you can manage. We talked about rigs for a minute. 2 VFOs is really a big deal. I don't find a preamplifier on 6 meters to be helpful. If you're into EME and you have a quiet location, have at it. 6-meter preamp right up at the antenna terminals would be useful, very useful. A preamp in the shack on 6 is nothing but increasing your noise level. Don't bother with it. In fact, there are a great many times. There's a great many times where I actually turn off the preamplifier, internal preamp to the transceiver, and actually dial attenuation in, and it improves the signal to noise ratio pretty significantly. Yes, sir. Oh, no, you can, if you have a quiet location, and particularly if you're into EME, you want to put potentially a preamp right up at the antenna terminals up off the ground, but not on the radio. My experience is you probably. Yeah, so here's an example where Norm's had a different experience. Yes. Well, so far you've proved that magic works. Yeah, I mean, Norm's in a pretty quiet location, I would deduce based on what I've seen him do, what I see him here. So, the preamplifier at the transceiver is probably not as destructive as it is in a noisy environment like what I deal with. But all right, and let's see. There's no such thing as QRP on 6 meters, to be honest with you. I would plan on trying to make sure you can deliver about 500 watts to the antenna. I've got an 8406. I can put 1500 watts up there into 10 elements, but I don't see any difference in results. And I'm not necessarily interested in replacing 3CX 1500 A7s, you know, so I run it at about 500 to 700 watts and do just fine.
You're waiting for 5 months.
Oh. Yes. Yep, I totally agree with that. And, you know, I've got a tube amp, both are tube amps. Seriously considered going to something like, you know, the SPE 1500 or whatever, solid state, you know, because of the no warm up. But sometimes I'm inattentive, and going back and forth from HF to 6, you know, if I forget to reduce the drive level from 200 watts barefoot on HF and fry a whole bunch of LD MOS, you know, I'll be divorced really quickly. So the tube amps are more forgiving of dodos like I am. But like you said, there's 2-minute, 3-minute warm up to deal with. So you should call. I mean, if you decode somebody on 6 meters at DX station, start calling them barefoot, because magic does happen that way. Yes, sir. No, I'm not. They sure look fun to me, though. That's one of the things I'm probably going to do this coming year, is try an SDR. There's a couple out there that are quite commonly used. And of course, the latest generation of radios, you know, they're coming out of K3 or out of Electcraft and out of, what's the other group? Flex. Are wondrous. You know, at IDXC, I was looking at the latest K4 and you know, the latest Flex radio, the 8600, I think it is. And, you know, frankly, I think that's where amateur radio is going to. I think radios like mine are probably not going to be useful in a couple of years, especially if you want to go remote. You know, you want something that's all digital. Next slide. Okay, operating practices, and then we'll wrap this up. FT8 is dominant now. There's, you know, unless you just like to hurt yourself, don't bother with CW and phone unless it's a contest. Norm, Rick may see something different, but I don't think so, because I got a band scope. 50.313 is where all the action happens until it gets so intolerably crowded that you can actually convince a European or a JA to go to 323. It's the craziest thing. All you have to do is get on ON4 KST or any one of a number of chat boards and say, I'm going to 323, and people will follow you there. But it's crazy. The band could be wall to wall during a major opening and nobody will move. But keep an eye on 323. That's where people move when it gets too crowded. This is important. When you're DXing on 6 and the band is open, Europe is first sequence always, and we are second. So if you're pointing your antenna to Europe and you're transmitting on first sequence calling CQ, bad on you. Bad on you. First of all, you're not going to hear any Europeans because they're all on first sequence. And secondly, you're going to piss everybody else off on 6 meters that's hearing you. And some of you guys, by the way, are plus 20, plus 30 down where I'm at. So you're not weak, you're strong. And I've got a neighbor, by the way, I won't give his call, he's not that far away, that continually calls CQ on first sequence during European openings, and he blanks my receiver. I put 30 dB of attenuation in and he's still plus 25. I can't copy anything else. I might as well leave the band. JAs and Asia in general is always second sequence. Okay, so again, if you're looking towards JA, China, BY, any of those Asian countries, they're always going to be on second of their DXing. Central America and South America is a free-for-all. They're a bunch of nutballs. There's no standard. So if you're pointing south, you know, southeast, do your thing, whatever sequence you want. As I said earlier, most openings last a few seconds to a few minutes. Now, during the E-season, that's not necessarily true. Openings can last all day and all night. But the true long haul DX, the stuff that's really pushing the boundary, you're talking about a very short period of time. So when you see the band starting to open, be there, right? Because what typically will happen is the band will start short. All of a sudden it'll go long, right? And it might last 5 or 10 minutes, and then it'll come back and retract again. And it might even go long a second or a third time. But what you're looking for is that second time where it goes long. That's when the path oftentimes extends by 50%. Propagation generally moves when it's sporadic E from east to west and from south to north. And again, there are obviously exceptions to that, but it generally follows the sun, right? As the sun makes its transit across North America, what you're looking for typically is the midpoint of the path. Where is the midpoint of that path? And that's where you want your antenna to be aimed to. Let's see. Spotting networks. Does anybody here want to even talk about this? If you're on 6, be on ON4 KST. Okay. Because not only do you get, a spot logger that you can look at, but you also have a chat going on where people are saying what they're hearing, what they're working. And so it gives you a good alert as to what's going on in the band when you can't hear it at the moment or can't see it at the moment. So if you're serious about 6, try to get on ON4 KST. It's a bunch of really friendly people. Everybody helps everybody. It's a good place to be. And obviously I use ham spots, DX Summit, DX Maps, and of course the local repeater as well. EME is Q6560A with a frequency that is very different than 313. Generally, those folks are down around 50.180 to 50.200. Don't operate down there unless you're on EME. Stay away from that. Give them a clear window to, to work in. And then meteor scatter is generally right around 50.260 to 280, I think is generally where they're at. So give them a clear spot as well. Stay away from those two sub bands, if you will. Next slide. Any questions so far? Yes, sir. Unless there's FAI, field align irregularities, pretty much where you think your beam should be pointed is where it gets pointed. If I want to work Europe in the morning during the E season, I'll point my beam, anywhere from 20 to 30 or 35 degrees. Africa, is typically 45 to, 85 or 90. So yeah, pretty much straight on beam headings. Yep. I'm not going to discuss this. I just wanted to provide you with a handy list of reference material that I found extremely helpful understanding 6 meters and particularly long haul propagation. All of these articles have been written by people I think that you all recognize. They're still readily available on the internet and they make really interesting reading. And these people are all a lot smarter than me. They explain how these mechanisms occur, at least to the best of their abilities. And it's I've also listed them here, by the way, in terms of the order that I think they're helpful to you. So there's a reading list for you if you choose to read more on this subject. So I think that should be a wrap, is it? Was that a wrap?
Yeah, that's the last slide. I do want to mention that on Zoom, besides Alan, we have 3 members from the El Dorado County Club, W6GLB, MERV, I want to say WA6QLY or something like that, and K1VUE, and also John, K6MM is on, and NU6T. I do have a question though.
Yes, sir.
And my question is, so these guys all know I'm a horrible DXer. I've got 340 and I don't know how the hell I did it. I'm more of a fair contester, and that's sort of where I work my countries. I've never even owned a 6-meter antenna other than a dipole, which is what I'm going to ask about until Rick brought over that KLM. So I'm in Massachusetts at W1, and I put up a homemade dipole on my chimney, and I could never just give a crap about 6 meters. But one day somebody called up, said 6 meters is open. So I went on, I worked at GW and EI and a G. Would those have been F2 from Massachusetts?
No, was it during the summertime?
Hell if I know, so long ago.
So it's interesting because the New England area has this pipeline to Europe that often nobody else experiences. That's why I asked about the time of year. That I would say that in all likelihood, if it was spring or summertime or even early fall, it was multi-hop E's, either 3 or 4 XEs into Europe. Again, when the band is open during the E season, dipoles will work, right? But the contacts that you got from the East Coast into G and GI, would be extremely much more difficult from here and probably not feasible with a dipole from the West Coast.
The Zoom folks, you can be heard. So if you have a question, go ahead and ask.
MU6T.
Yes, sir.
Yeah, go ahead, Rich.
Thank you for your question, because that was kind of one I was going to ask today. We actually had an interesting opening or series of openings this morning, and I'm just using a vertical antenna, and so it's nothing great, 500 watts. And this morning I worked Florida, I worked up into Alberta and British Columbia, heard Mexico, but didn't make contact with them. Got a whole bunch of folks around the Western US, and kept trying to get some people with 1s and 2s and things like that, but they all turned out to be in Arizona or California or Washington State. But I was curious about the Florida contact. Would that be an F2 skip, or do you think it's E skips?
Oh, I'm pretty sure at this time of year it would be E-skip. The season's starting to fire up. Again, it was Rick, right?
Rich, yeah.
Rich, one way you can tell is were you hearing stations in between you and Florida? If you were, for instance, if you were seeing or decoding Arizona, New Mexico, Texas, then for sure it was E's. If you were hearing nothing else except Florida, then there's a good chance it was, F.
Yeah, I probably heard as far as Colorado and Utah, but I didn't hear much of the Midwest. Didn't hear much of the South, but Florida popped up, and I just was surprised.
Yeah, I would say this time of year it's E-skip for sure. When you think about it, it's only 2 hops, 2 E hops. So again, a single E hop can be anywhere from, say, at the short end, typically 1,200, 1,300 kilometers to a maximum of 2,200. So you only need 2 hops to get to Florida at the maximum end. In fact, you don't even need it at the minimum end, basically.
What I was noticing was that I would see a bunch of FT8, I would see a bunch of contacts and be able to make a few. Some were really strong and a lot of them were mild. And I had a number of QSOs where we started off great and then we couldn't complete it. And so that I thought was probably E-skip.
Yeah, and that's kind of what, you'll see domestically the same problem that I talked about, internationally, or DXing, which is the conditions often change in a matter of moments, a few seconds to a few minutes. So you experienced, exactly what I was talking about.
Yeah. Thank you very much. Are your notes going to be available?
I'm sorry. What was the question?
Your notes, your slides?
Oh, yeah. And by the way, anybody that wants a hard copy, or not a hard copy, an electronic copy, just send me an email. I'm good on curozed.com. I'd be happy to send you the file if you want it.
Thank you.
You betcha. Yes, sir. On 6 meters, never. Nope, never. Oh, the question was, do I ever pick a quiet frequency other than FT8 and just get on and call CQ? And the answer to that is no, never. Not in a decade or so anyways. The chance that anybody's going to find you on anything other than FT8 these days on 6 is remote. Every once in a while, I'll see a CW or a sideband signal on my band scope, and I'll just go down and listen to see who it is. And if it turned out to be Turkmenistan or something, I'd certainly give them a call, but it's usually somebody who's not been on 6 before, or I don't recognize them on 6 and they're experimenting. Yep. Oh, yeah. I mean, there's nothing. Yeah. So there are still beacons on the band. So the beacon band is basically 50.000 to 50.080. So if you can see that band spread, and you see signals down in there, the band's open somewhere. So go down and find out who it is, which, or if you see a signal on sideband or CW, go listen, and that'll be a good indication of where it's open. But in terms of time efficiency, park your receiver on 6 on FT8, unless you just hate that mode and you don't even operate it. And, if you have a vertical on 6 or a small antenna, like a 2-element, where it's got a pretty broad pattern, that's the best way to figure out what's going on the band, because everybody's on 313, literally everybody. Yes, sir. Polarization. Yeah. So the question is, what about polarization? Other than EME, everything else is horizontal polarization. So I'm not sure I understood the question. I apologize. Are you talking about do we see polarization shifts?
Yeah.
Yeah. Yeah. I think we do. It's, often we just think it's QSB, right? And it's not necessarily band fading or changes in the E cloud itself, but it could be polarization shifts caused by those things. So yeah. And again, a stack will help. The more capture area you have, the less likely, you're going to suffer from that kind of phenomena. It's a good question. Any other questions, Norm?
South America,
Yep.
County statements. If you're doing that, and all of a sudden there's something that comes in that you don't believe. That's in the wrong direction. For God's sake, don't turn your antenna to it.
Yeah.
First got out the air. Yeah, good openings, due south, and it's carried out. All of a sudden, KX6 came on. I stupidly moved it, then I had lost it. The back scanner is very.
Yep. So for those on Zoom, Norm's point was that if you're pointing somewhere and you hear something you want to work and you think you're pointing in the wrong direction, don't move your antenna, work them. That's great advice. Yeah. Yep. 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 So Norm had the same experience with 7X2 RF, I think it was, that I had with 9K2 GS. Right. When I heard 9K2 GS, he was working a station in the South Pacific. And I thought, holy mackerel, that's off the back of my 10 elements. So I started turning the antenna and watched his signal strength go, gone. So I quickly backed it right back to 140, and there he was. Right. But if I had kept on going, that prop pitch rotor came to a screeching halt when I got like 40 degrees off him and reversed it. But any other questions? Okay, well, hey, guys, thanks for inviting me. Bob, Steve, thanks for giving me the time. I'm an evangelist when it comes to six. Hopefully those of you that aren't too serious about the band, might give it more attention based on today, I hope. Love to see you on there and love to be shoulder to shoulder with you, beating our heads out on working a new one.